Hello, HVAC friends. I'm Dirk Nauman with HVAC Simulator, and today we're going to demonstrate the gas furnace electrical troubleshooting simulator. If you know students or technicians who struggle with schematic reading, with potential difference, and assisting them with whether or not the switch is open or closed, or with the sequence of operation or component functionality, this simulator will help you with all of these issues. This is an 85-page curriculum, so let's take a look where you can find this. This is hosted on the ESCO Institute's Learning Management System. Click on the e-learning. Will take you to this page. Click on the courses and then look at all of these awesome courses. There is a lot of information on here that can get you to the next level technically. But we're going to look at the HVAC simulator and demonstrate the ICP product. There is a student version and also a instructor version. The instructor version has all of the answers. So looking at this simulator, when you go into the link, this will be the main page. There are all of the IOM manuals, installation, operation, and maintenance manual. King of Knowledge doesn't necessarily get you as far as it did 20 years ago. Now it's the king of literature. Where do you get the literature to diagnose these furnaces? You have to have the literature. So all of the literature is available. This is electrical troubleshooting trainers, so all of the electrical information is towards the back of the manual. Second to last page, we can see the connection diagram, schematic diagram, and there's going to be some flow charts, and then all of the fault codes. But we do not need that because all of this is embedded in the simulator. So sequence of operation is just a process. We begin by giving the thermostat a call for heat. And then we check the process. Follow the process. If you follow the process every time, it will get you to the solution. So the first sequence in the operation is a call for heat. We have 24 volts. The second sequence in the operation is the inducer. We can see the inducer is on because of these indicator lights. These indicator lights represent what you can see or hear in the field. Then the next sequence is the pressure switch. I always have technicians check the pressure switch on the printed circuit board. I do not recommend going out to the pressure switch and pulling wires or tubing off the pressure switch because pressure switches are sensitive, and if you start pulling wires, you can easily change the state of the pressure switch. Then the igniter. The igniter has already cycled off because the burners are running. So, but if the burners are on, therefore the gas valve has to be energized. And if the gas valve energized, then we're going to have flame rectification, and then finally the blower. This is a constant torque ECM motor. So when the board sends out the 24 volt signal to the module of the motor, then the motor is energized, which we can see that the indicator light is on, so therefore we know the blower is running. So the red test points, they measure resistance. The transform, the hot surface igniter. As stated earlier, this is a constant torque ECM motor, so all of the windings are going to be equal. And then a inducer is a PSC motor, so therefore 2 of the 3 windings are going to add up to the 1. Awesome. So now let's get into the faults. So there are 16 faults in the curriculum, and the push button acts as a service switch. Think of the push button as a service switch. There's a switch on the side of the furnace. If you turn it off, it restarts if you turn it back on. So that's all it does. So when you think you found the fault, just hit the push button and restart it. So if you follow the sequence every time, you will catch the fault. So there is a call for heat, then the inducer, pressure switches. Then we can check the pressure switches out here if you like, but I always recommend to check them on the printed circuit board. And then the igniter. Well, the igniter has yet to turn on. We are sending 120 volts to the igniter, so something is wrong because it's not glowing. So therefore, this is going to fault out. If we don't have an igniter, the gas isn't going to ignite. Pretty simple, right? But let's count the faults. There's going to be a 6 fault light. And then we can go to the service fault codes. A 6 is ignition proven failure. So we can go back, and the way I teach schematic reading is go to the component. The component can always be a possibility of the failure. Not always, but this is where I recommend students start. So looking at the hot surface igniter. The hot surface igniter can be a failed point or this relay, the hot surface igniter relay. But if the inducer is on, then this power is sitting at the hot surface igniter relay. We measured this. We saw there was 120 volts. So there is not any other possibility besides the hot surface igniter. And how do we check the hot surface igniter? We measure the resistance across the hot surface igniter, and we can see that we have OL. So infinite amount of ohms across the hot surface igniter or open line. So this will help with potential difference. There is a section completely covering potential difference and how it helps you determine whether or not the switch is open or closed. There's a sequence of operation and then following the process. There's a knowledge check. 85 pages in this curriculum. We hope you enjoy this, and please try this out and go to the ESCO Institute's website under e-learning. If you have any questions, you can contact us at hvacsimulator.com.